terminal velocity. So let's talk about parachutists. AQA seems to like parachutists. There's lots of questions about them. Now, when they jump out of planes, they accelerate to start with because their weight, due to gravity, is much greater than drag because their velocity is initially low when they jump out. But as they accelerate, the effective air resistance, or drag, increases, as we explained a minute ago. And this acts against weight, pushing upwards. Now, as the fall continues and velocity increases, the effective air resistance will also increase until it reaches the point where it equals the weight. And when the two forces are balanced, the parachutist can no longer accelerate and falls at a constant velocity. This is called terminal velocity. Now, terminal velocity is dependent upon the surface area of the falling object, because a greater surface area has increased air resistance. So terminal velocity won't necessarily be the same for every falling object. Now we can work out the acceleration for a falling object. If it's in a vacuum, there are no particles present, so there's no air resistance. So the only force acting upon a falling object in a vacuum is its weight. Now on Earth, G equals 10 newtons per kilogram. So the acceleration for a falling object weighing 1 kilogram is 10 divided by 1, which is 10 meters per second squared. Now, how did I work this out? Go back to this lovely triangle, FMA. The acceleration is force divided by mass. Now, the force is 10 newtons per kilogram, and there's 1 kilogram, so it's 10 divided by 1, which is 10 meters per second squared. Now, in most cases, the object is falling through a fluid, not through a vacuum, and so the particles of the fluid exert a drag force. The size of the drag force increases as the velocity increases. Now, when it reaches the point, when it's reached a high enough velocity that the drag force is equal to the weight, terminal velocity is reached. And that means that acceleration is 0. Now, what this means is that the drag force must be equal to weight, because if it reaches a terminal velocity and there's no acceleration, then there must be 0 resultant forces. So weight must be equal to drag force. So for a 1 kilogram object, the drag force is 10 newtons at terminal velocity. So let's look at it visually then. Parachutist has just jumped out the plane, and initially acceleration is rapid because the weight is large and air resistance is very small because his velocity is very low when he's first jumped out. And as the parachutist falls faster, air resistance increases, and eventually air resistance is equal to weight. So terminal velocity is reached. There's no more acceleration, he's falling at a constant speed. So, at terminal velocity, drag is equal to weight. So the resultant force is 0, and acceleration is therefore 0. Now you may be asked to draw graphs for objects that reach terminal velocity, and you may be asked to show the forces and explain the forces acting upon them. Back to our jolly parachutist again. So the parachutist shown recorded the following data on a jump. Plot the data on a graph and explain the forces at each stage. So why don't you have a go at this? Pause the video and have a go at plotting the graph and explaining the forces. So your graph ought to look like this. The first part of the graph shows that the parachutist is accelerating because weight is greater than drag. The line levels out, he's reached a steady speed, he's reached terminal velocity, and this is the point at which drag equals weight. There are no resultant forces, so no acceleration. Suddenly he starts to slow down. He's opened his parachute, and this increase in surface area causes an increase in drag force. This part of the line shows deceleration. Drag is greater than weight, so his velocity is reduced. There is a resultant force. Now, he might well reach a steady speed again. This is the second terminal velocity, where drag equals weight again. Now, how does that happen? Well, in the descending part of the graph, drag is greater than weight, but don't forget he's slowing down all the time. So what happens to the effect of air resistance as a falling object is slowing down? Well, air resistance decreases because the particles are hitting the parachute less frequently and with less force. So drag is actually decreasing as he slows down. So he'll reach a point where drag has decreased to the point where it equals weight again. So he'll reach terminal velocity 2.